Assalamu alaikum. In today's lecture, we see half subtraction and full subtraction circuit. The last class was about the half adder and full adder. So before continuing with half and full subtraction circuits, I'll just revise what is full adder and half adder. Okay. So first we'll go and see what is a full adder and what is a half adder. This is just the last class. We have already done the activity, might be. Okay, now this is experiment 8, half adder and full adder circuit. So to understand what is half adder is nothing but adds two single binary digit A and B. It has two output, sum, that is S, and carry, it is C. You can see it here. I'll show you. This is sum, this is carry. Okay. So the carry signal represents an overflow into the next digit of a multi-digit addition. When you have two addition of numbers, then there will be an overflow and it will represent a overflow. So the value of sum is 2 bits, that is A plus B, okay, which gives you the sum. And the simplest half adder design is shown in the picture. You can see A and B are the inputs, okay, and these A and B are connected to XOR gate. This is an XOR gate. They are connected to an XOR gate which produces sum. Then A and B are connected to AND gate which produces the carry, right? So with the addition of an OR gate to the combination that carry the output, two half adders can be combined to make a full adder. So the circuit what you are seeing here is a half adder circuit. I will tell you again, A and B connected to an XOR gate which gives you a sum, and A and B connected to AND gate which gives you a carry. So this is half adder, right? This is half adder. Next, what is a full adder? If you see the symbol of a half adder, it is very simple. A and B, two inputs. The output is sum and carry. Now, if we see about the full adder, what exactly full adder is doing. Right? Now, see here, in a full adder, what happens? If you combine two half adders, okay, it will become a full adder. How we are going to combine two half adders? The half adder adds two inputs, right? But here the full adder will be using three inputs A, B, C. These are the three inputs A, B, C. These are the three inputs, and F3 and F5 is shown here. That is your sum and carry. F3 is your sum and F5 is your carry. Okay. I will show you the diagram now for a full adder. See, the simple method to connect two full adders. What you have to do, A, B, and this is sum is coming here down, and this is the carry. So sum will give you an input to the next half adder. Then this is C in, this is carry in pin. Now here you will get the sum, from here you will get the carry. So in simple symbols, if you see A, B, C, I, we are writing. Ci is nothing but carry in. carry in pin. Okay, if a carry is generated, that is a carry in is given here. So sum and carry. So this is a full adder circuit. So this is by using the trainer kit. If you come to the physical class, there you will see this on the trainer kit. So this was about the last class. Now in today's class, see what you have to do is you have to fill this table A, B, sum, carry. This is for the half adder. Right? For full adder, the same thing. A, B, C will come. Okay? F5 is your sum and F3 is your carry. Okay. After that, in the activity, you have to design the truth table for the circuit 1 plus 0 plus 1. 1 plus 0 plus 1 means this is A as 1, B as 0, and this 1 is your carry in pin. So you need to write the truth table for A1, B0, and CI pin 1. It is very simple. Solve this activity. I think you might have solved this last week. This is I am telling about the last week. So now in today's lecture, we will see half and full subtraction. So now the concept of half adder and full adder might be clear to you. So before that, we will see first what is a subtractor. Okay. So what is a subtractor we will see. Then you will come to know what is half subtractor and full subtractor. So subtractor is nothing but which is used to subtract two binary digits or two binary numbers and provides a difference. In the previous one, full adder and half adder, you are getting sum and carry. The output are sum and carry. In half subtraction, you will get difference and borrow as the output. Okay. So subtractor, you will get difference. Instead of sum, you will get difference, and instead of carry, you will get borrow as an output. Okay. So in digital electronics, we have two types of subtractors. One is a half subtractor and a full subtractor. So what is a half subtractor? A half subtractor is nothing but it is similar to the half adder what you have seen. It is used for subtracting one single bit binary number from another single bit binary number. So like the adder we have seen, here also we need to calculate the equation of difference and borrow. So what is the equation for difference and borrow? A dash b plus a b dash. It is nothing but XOR function we are talking. Okay. Here also you require an XOR gate. A XOR B will give you the difference, and borrow is nothing but A dash B. A dash B is nothing but A bar into B. That is A bar with an AND gate to the. So if you see the logic diagram for the half subtractor, which is now shown here, it is same as your half adder. Okay, it is same as your half adder. A dash B plus A B dash. This is your A XOR B function. Okay, this is A XOR B function, which will give you the difference. In half subtractor, you have seen this is giving you sum. Okay, so here you have two inputs A and B. A and B is given to the XOR gate. The output will give you the difference. But in half adder, it will give you sum. Okay, now this is a half subtractor. So the only change what you see here is you are getting here A dash. A dash means not of A. See here, A dash is nothing but not of A and B. This is not in between. This is means and. So only difference what you see is this one. I will mark it. Only difference what you are seeing is this one in a half subtractor. Okay. So you are putting a NOT gate here and it becomes the borrow. So difference and borrow. So this is a half subtractor. What is half adder? Without this, it becomes a half adder. Understood? Without a NOT gate, it will give you the output of a half adder. Now with not, it will give you the output of a half subtractor. Now we see what is a full subtractor circuit. So the logic circuit which is used for subtracting three single bit binary digit is known as a full subtractor. So what is the difference and borrow will be written as, if you see, the difference is written as a dash b dash c plus a dash b. This is c dash, not b dash. Okay, this is c dash. This one I will mark here. This is, instead of this, it is c dash. This is c dash. Okay, this is wrong. This is c dash. Right, this is c dash plus a b dash c dash, then a b c. So if you reduce it to, then it will give you a XOR b XOR c, same like your full adder, a XOR b XOR c. Okay, this is by using the formulas. Okay, now we need to see about the borrow. So what is your borrow? A dash b dash c plus a dash b c dash plus a dash b c plus a b c. So this will give you the borrow. So in short, if we reduce it, it will give you a dash c. Okay, then it will give you a dash b, then b c. It is your borrow in full subtraction. If you see the circuit diagram, it is similar to what we have seen in full adder. So the difference between the full adder and full subtractor is a NOT gate, what you see here, and NOT gate, what you see here. Okay, right? So these two NOT gates you are using in a full subtraction circuit. So difference is here, borrow is here. This is a full subtraction. You will have difference, borrow, and this is your carry, right? Carry. You call it as a borrow here in subtraction. So here the inputs are A, B and C. Now if you use the KL kit, the hardware kit for doing this experiment, then you require this diagram, which you are not doing. So you are doing it by using the simulator, that is electronic workbench. So no need for this diagram. This diagram is required only when we are doing it on the hardware kit. Very simple, just we need to connect the circuit like this. A1 you have connected, check the output from F3 and F5. So now how to write the truth table. So this truth table is for the half subtractor A, B. Difference F2, from F2 you are getting the difference and borrow. This is the table for half subtractor. You need to fill this truth table in the sheet. Okay, now we see the truth table for a full subtractor. For the full subtractor, this is the connection you are doing, A1, A1 above this one and A2 this one. This is also for hardware. Now you are doing it in the software. So what is required is A, B, C, difference and borrow in a full subtraction. Difference and borrow is used in a full subtraction. So you need to complete both the tables for half subtraction and full subtraction. Write it in the activity sheet. Then after that, you have the activity for today's lecture is design a truth table and a circuit diagram for 1 minus 0. So this is about half subtraction. 1 minus 0 means A you are taking it as 1 and B you are taking it as 0. So write the truth table for this. So this will give you the answer for today's class. Okay, very simple exercise. You just do 3 minutes for this one, solving this one. Already I have uploaded the activity sheet. Activity 8, the number is activity 8 for this one. Solve the activity, send me through the course message. Okay, I am seeing many of the students are not sending me the activities. So please send the activities on time to avoid losing the mark. Okay, and one more announcement you have, that is we have online exam for this. Okay, for all the practicals we have the online exam. So I am available here. If you have any questions or doubt, you can ask me. Okay, or you can visit office hours during my office hours also if you have any doubts. Right? So this was about half subtraction and full subtraction.